Welcome to another edition of the Sim Racing Garage. I'm Barry Rowland. In this episode, we will be reviewing the extended 3DOF actuator system from Qubic Systems, whose parent company is Motion Systems, which has been making some pretty cool looking motion simulators for the simulation industry for quite a while now. Time to put their QS220PL 3DOF kit through the SRG's review process and see how it does. So, let's get to it. Let's take a closer look at this QS220PL actuator kit from the guys at Motion Systems. Now, this is part of their Qubic system, they're calling that, and that is a modular system. The modules consist of two actuators and a controller box over here that we'll talk about later. Each one will have two actuators and a controller box. I have two of these. These came in a commercial retail box. I'll give you some B-roll of that so you can see how it was packaged. Everything made it safe from Poland. No dings or any bad gashes or anything anywhere as far as the actuators and the controller box went. So yeah, that's always good. The actuators themselves have a nice kind of a powder coat looking finish on them, and they have these red accents, as you can see. These are very large elements, but let's talk about the specs first. So I'm going to use the Qubic system product card to go over the specifications. Now we have a specification here under their title sheet, or the first page, that has some pretty great numbers. 800 millimeters per second for a 100 millimeter stroke. That's very fast. In fact, I'm not even sure where you would use that kind of speed, what you would need for that kind of speed, especially over 100 millimeters of stroke. But yeah, there it is. Maximum control frequency is 1000 hertz, and we have 0.8 Gs of acceleration. That's the maximum, and latency is less than 8 milliseconds. And we have a thing called vibrations frequency range here, which typically means there's some kind of a haptic feedback element in the system for engine vibrations and things like that. But let's break this down. Here we have general specification, and you can see what we just saw here, which is the 800 millimeters per second and the 200 kilograms of weight limit. Didn't see that before, but that comes out to about 440 pounds. But you'll notice up here in Q mode, that's at 230 volts, right? And 441 pounds is not a lot of weight for a motion system, considering you have to have your cockpit on there. My cockpit weighs about 100 pounds. Me, I'm 155 to 160 depending on the day. And yes, so with your controls, like a decent direct drive, force feedback wheel, a seat, and pedals, even without, a separate shifter and stuff, that 441 pounds is going to be close for me. But I'm going to run it at that for sure, just to see what the differences are. Now, over here we have performance mode and heavy duty mode also available. So all three of these modes are built into the system. Now, if you'll notice, the first thing about these two modes over here is we can actually run these also at 115 volts, which is the North American voltage where I live, or again, 230 volts. But Q mode must be run at 230 volts. And reasons are obvious. We can really put more amperage through the system, even though we are losing capacity as far as weight. Now in performance mode, we're coming down from 800 to 400 millimeters per second. Still a lot of speed for a 100 millimeter travel actuator. Plenty in my book anyway. Might be somebody argue with that, but I think that's plenty. I'm running actuators that aren't close to that, more like 300 over here, that are doing a great job and about as fast as I could ever want. And that's on 6-inch length of actuator as far as motion goes, or movement. Now, also we come down to 0.7 Gs on the acceleration, which is a little bit less. Can you notice from a 8 to a 7? I'm thinking you probably can't. But the weight, look at that, it goes up another 50 kilograms. So now we're talking 551 pounds, which is going to put most any driver I could think of in a very safe position as far as, adding their cockpit and their wheelbase, pedals, and a seat. And maybe a shifter, a button box, things like that. 551 pounds is good. We go to heavy duty mode over here, and same thing, 115 or 230 volt, 300 millimeters per second, which is still at 100 millimeter stroke, more than ample in my book to feel what the suspension of a car is doing. Now, going over maybe big launchy jumps or something, you might feel a difference, but I still think the speed is there to simulate what the suspension does, even like a jumping truck, like a Lucas Oil Trucks in iRacing or something. Now, you can see that our acceleration, though, has come down to 4 Gs, or 0.4 Gs. So definitely a hit on acceleration. And I'm not sure what difference that's going to be in the feel. It's going to be smoother feeling, that's for sure, because it can't push as hard or as quickly. But look at your weight over here. It's gone up to 350 kilograms, 771 pounds. So here we can put all kinds of accessories and things on your cockpit without ever worrying that you're ever going to exceed the limits, I would say. All right. Anything else we want to look at here? Just actuator stroke. We already talked about that. 100 millimeters, 3.9 inches, 4 inches for practical purposes. And the other frequencies and limitations have not changed. All right, so I just want to go over the specifications because, yeah, 3 different modes. I'm going to run my system, obviously, in all 3 modes to see what the differences are. Again, 800 millimeters per second. That's very fast for 100 millimeters. And I don't even know if that makes a difference, because if the telemetry stream is the same, if it's going to change the feel of it. It may not. It may make it so fast and so jerky that I don't like it. But that's what I'm thinking. But we'll never know, obviously, until we get in and do some testing. And we'll get to that segment when we get there. So there it is, the specifications for our Qubic system, the QS220PL. So we'll finish our closer look with all the rest of the parts that come with your kit to get you set up and running. First off, we got this documentation. And we've got a couple little booklets here, little spines, clamp-on spine. And these are QA reports, quality assurance reports. And this one is for the emergency stop and our M10 conversion box. At least that's what I'm calling it. It's signed by the technician that did the quality assurance checks. And it has some information in here about what pieces got passed or didn't pass. Well, obviously, if they didn't pass, they wouldn't be here, right? So they're all passed. But yeah, this is kind of neat the way they present this. Anyway, we got one for the, again, emergency stop and the little box we'll talk about in a second. We also have one for the QS220PL kit itself. And I believe it's the same, same technician that did this one too. You can see his signature down there. So that goes through the same thing, all the parts that they checked out on these actuators before they shipped them to me. And they tested things like the dip switches, make sure they were operating properly. All right. And the main attraction is going to be this manual, the QS220PL manual. This is where we're going to get all the information we need as far as where we can set it up or how we can set it up, the configurations. It tells you, and again, I was going to show you this one here where you can just have one of these kits and buy the pivot. You can see the pivot over here, that little thing sticking up that's sitting on the chassis there, that allows you to do a 2 DOF setup. And of course, on the bottom there, and you can see, by the way, the weight limits. Again, that's 250 kilograms for 2, so that's 125 each, or about 275 each as far as pounds. And we have 350 total for a 4 actuator kit. So yeah, that's probably going to be plenty of weight, I would imagine. 275 a piece. That's like 1,000 pounds, I guess. Also, the important data for connecting your computer up, or your system up to the computer, and how to route all the cabling. And we'll go over that once I'm actually setting mine up. And depending on the configuration we're using, and I'll be using, I believe, this one, how to set our dip switches on the back of the controller box that you saw in the, when we were doing the closer look on the controller boxes. There we go. So I'll be using one that has the 1, 2, 3, 4 over here, this guy. And it tells me how my dip switches need to be set. So don't lose your manual, obviously. Let's talk about this M10, they call this. And this is the little conversion box. It has the same finish, same aluminum. It's aluminum all the way around. Again, very nicely done. This seems to be etched on. It doesn't seem like a sticker. Little etched in logo there. And this is the M bus. And the M bus is the data communication between the controller box in here and the other controller box, because remember, I have 2 of these kits for 4 actuators. We have the RJ45 plug for that, and we have the micro USB plug that will go to your PC. The emergency stop. This is a industrial type of emergency stop. It's not metal. It's a real tough plastic, though. There's no flex or bend to this casement anywhere. So, of course, if you have a problem, we'll push that in, and then to unlock it, we just twist it counterclockwise. It'll pop back out, just like most emergency stops. And it already has the plug on the end. And again, they're using these terminal blocks with the screw down connectors. So yeah, that's not coming off. And that will go back in the back of our case that we saw. If you closer look, we have those green plugs right over here. Oops, over here. I'm in reverse. So those are, they call these the ML down, ML up. So we'll be connecting to that. And of course, there's those dip switches we were talking about. And we'll use one of these. If you had just one of these systems, you'd be using one of these M-bus plugs. But we're going to be using two because we're going to have a daisy chain where we're going to have it going over to the other controller box so they can all talk to each other. Again, we'll get to that once I have it set up and cabled up. We'll take a look at that. And you get all the cables you will need to do that. You get the RJ45. And again, all this is shielded. You can see the metal piece on there. And this has a clip-on ferrite choke, or filter, if you will, ferrite core. And yeah, good quality cable, it seems like. And again, this is the M-bus cable. I've got two of them because I got two kits. And if you get two kits, obviously they're going to give you two of them. This is the also a communication cable that goes between both of the controller boxes. Again, we'll see how all that comes together once we're there. And this is just another, yeah, this is the extra M-bus cable that I will use for connecting both of them too. So it's like we have two connections for both of them. We also have a power plug, and this is for a 115 North America type. You can see the type of plug that is. Over here we have the normal computer type plug. And it has, again, a ferrite choke on it. And this is a square one. And it is a clip-on unit. It's not integrated in the cable. We have a small USB cable that will go to the M10 box that we just saw over here. And that obviously was going to plug in there. The other side's going to go to the controller box. And then this side will go to the PC. Now, it's going to be a long cable for the M-bus cable, so I imagine I'm going to have this closer to my PC and not on the rig, because this cable they give you for the USB Mini is not very long. Maybe half a meter or so. Yeah, it's not very long. We also have this plug, and this is the termination of the daisy chain plug. And it's just a simple plug that has two pins. It's RJ45, obviously. And it has two pins that, I don't know if we're going to be able to see that. They have a wire in there. It's just a loop. So that wire goes in here, loops back out to the other side. So the signal comes in, it comes back out. It just reflects the signal, if you will. Kind of like a network cable loop, testing loop piece that we used to use in the networking industry. What else do we get? Oh yeah, we get these. These are important. These are the cups that come with it. And it looks like they're made out of Delrin because it's slick feeling, but it's very, very stiff at the same time. And of course, it has the red accent. It has kind of a sticky foot, rubber foot on the bottom. And I don't know how well this is going to show up, but this is a concave. It's not flat down in here. It's like a concave form. And of course, that's going to fit back here on the actuators as they're sitting on the floor like this. And it's going to allow the actuator to move around a little bit. So this is what we call a non-captive foot, or landing, however you want to say it. And we get two of these with each kit. Of course, I have four of them because I have two kits for four actuators. What else? Oh yeah, we got some hardware here for attaching your controller box, and I believe your actuators, but I think this kit comes with your brackets. And we got some spring ball T-nuts for that. We have some 16 millimeter long M8s to be like, I think these are stainless. And we've got these smaller ones that I don't know what these are for yet, but I'll find out as we move along, I'm sure. Might be for our kill switch. I don't know. We'll have to wait and see. All right, so what else do we get? We're going to take a look at the brackets I'll be using to mount these actuators to my cockpit. Now, these do not come with your kit. These are separate. You order them separately. And the reason that is because they sell a lot of these systems to motion system integrators. So those are people that will just take this piece right here, the actuator, and of course the box, and mount it to whatever kind of motion system they're designing for whatever they're using it for. So that's why it doesn't come with brackets. Now the brackets are available, however. They come in at 60 euros a piece for these brackets. Now that's a lot of money for brackets in each one. So you're looking at 240 euro for a set of these brackets. Not cheap, but I will tell you this, you will get a quality product if you do decide to go with their brackets. This is 4.3 millimeter thick steel. You can see they put it in a big press, big industrial press when they stamp this out. Yeah, it's just a heavy duty unit. It comes in at 4 pounds, 14.5 ounces, so almost 5 pounds for one of these brackets. and that's 2.23 kilos for everybody else in the world. Again, something that you need to be aware of, that these do not come with the system. So depending on how you're going to mount your system, you have to consider what you want to do with that. Now, they have a universal fitment on the back of this. And you can see these holes on the outside are the holes that I'm going to be using, or you would use for like a profile. What we have here is a distance of 120 millimeters between this hole down here and the hole over here. Now, between this hole and the hole before that one, that is 80 millimeters. And then the hole here and the hole here is 40 millimeters. And of course, it's just 40 millimeter spacing all the way down. You just add whatever you're going to be using, a 120 profile, a 160, or a 80. Now, all these are 40 series. So that's 40 by 80, 40, 120, 40, 160. And they have some holes on the inside here too. Now, they also have these two big holes, and I'm not sure what they use for these. These are 45 millimeter centers on these big holes. Now, a typical M8 bolt with a socket head cap like this is going to fit right through there. So I'm assuming it's not for that, but it might be for something else. In fact, they might have some implementers out there that they have a certain type of style of bracket that they can offer them in their CAD drawings and things, and maybe it takes advantage of those holes. Who knows? And we also have some holes that are spaced 45 millimeters from center to center down here. Not sure what those are for. I'll be using these, and this is how I'm going to mount it. Now, there's a couple of ways I can mount this. I'm going to grab a piece of profile here to demonstrate, and this is only a 4080, but it'll serve the purpose. I can mount it this way with the holes down here, like so. Remember, the holes on the housing here of this actuator's housing is how we're going to be mounting into these holes. Of course, they match. And if I line this up, they will be sitting, this bracket sits a little proud. You can see how it's not really on top of the actuator itself. Drop down on top. And of course, that is so we have clearance for the bolts on here that we're going to be used to attach the cockpit so it doesn't rub up against the housing. Now, back to what we were talking about. I'll put this down where the holes are, and I'll just let it rest. And let's say this is my profile. I'm going to put it down here somewhere, right? And mine's a 160, so I'm going to be using the extreme opposite holes here. But yeah, if I mount it like this, and I'm going to put this where it would be centered on the top hole, so I have this much actuator sticking up from the bracket. So that means above the top of my cockpit base rails, that's how much I'll have extension on the housing. I don't want that much housing sticking up. I want the least amount possible for clearance issues. I mean, if I put something else on the cockpit, or if I'm using a shifter, and because I have to have the actuator close to where my arm is behind me, along where the seat is, and I'm hitting it with my elbow or something. These are things that I think about when I'm going to install a system. Now, if I take this bracket and flip it around, though, things change a little bit. Go ahead and set it back down here even again. Now my bracket is going to be up here. The top of my series bracket is going to be right like that. All right. So now I only have this much actuator housing sticking above the base of my cockpit. So for me, the way I like to build cockpits, especially with motion attached to them, the less sticking up, the better. So there's two ways to do it. I just want to show you both ways. So yeah, not much else to go over here as far as a bracket's concerned, right? Big honking piece of steel. It has a nice coating on it, matches the rest of everything, of course. Very professionally presented like everything else with the motion system stuff. Like I said, all their stuff looks good. All right, so we'll get on to the next segment. Now let's take a closer look at the controller box as part of the QS220PL kit. First thing, we'll talk about the dimensions of it. It's a fairly large box. It comes in at almost 15 inches long, which is about 385 millimeters. And width on this is just under 11, we'll just call it 11 7/8 of an inch. Height, there are no feet on this, comes in at, let's see, about 90 millimeters, or about 3.5 inches. The weight on the controller box is 11 pounds, 10.5 ounces. So it's not a real light controller box either, which again is kind of like the actuators. You know, the heavier weight lends to an impression anyway of a more commercial heavy duty built system. So that's 11 pounds, 10.5 ounces, or 5.29 or 5.3 kilos. It has the same finish that is on the actuators over here that we saw previously. And it's very good everywhere you look. I don't see any dings anywhere, any imperfections. Fit and finish are very good on this unit. Yeah, no complaints there. The top has some fans in it. We have a fan here and a fan there, and that's probably a couple of circuit boards in here being covered by that, which is going to suck in the air here and it's going to blow it out on the vents here, and we have another one on the other side. The top is a one-piece aluminum plate. I believe it's aluminum. And they also have a cutout for their logo here, the Qubic Systems logo, which is also another aluminum plate with the logo for their Qubic system. It's kind of neat the way they did that. So you can see it's kind of a two-dimensional thing going on there. What else can we talk about on the top? That's about it on the top. Let's talk about these cables. These are very thick cables like you saw when I mentioned over here on the actuators when we did a closer look on those. These are fully shielded cables. They have a wire mesh just inside of this rubber casing on the outside, and that is pinched in here on these cable glands to the chassis. Of course, cable glands are attached to the chassis. The chassis is completely grounded, so the shielding gets grounded to it at the same time by the way it's pinched in there. We have obviously two pairs of these because we have two actuators, and we have numbers on them, 1 and 2. And this will be something you'll need to reference when we're actually configuring how we're going to be running the system. Is it going to be just a 2 actuator system or just one QS22PL kit like this? Or is it going to be like I'm going to be doing? I'm going to be running 2 of these QS220PLs. So the configuration matters, and we'll get to that once we obviously start configuring it. The side case has an M8 bolt here, a hole rather, here and here for mounting. And on the other side, we have the exact same setup. You can see the other vent hole there, and you can actually see some components in there. On the flip side, you can see we have lots of these screws in here, and these are probably holding in components, obviously, like circuit boards, standoffs for circuit boards, things like that. We'll get to the look inside and see what's going on once we get to that point. Now, I'm going to show you up close here, if I can do this without stretching my actuators out too much, the information that's on this sticker. Now, again, you can see it's the 220PL, and Motion Systems, the manufacturer in Poland. And important thing I'm looking for here is this input. And you can see it's either 115 volt or 220 volt. And we have 10.8 amps or 5.6 amps. So it's an auto switching power supply, obviously, in here because there's no switch back here, and we'll see the back in a minute. So you want to just plug it in and it's going to work, basically. So we also have a serial number here, and that's an important number too, because you can't download the software for tuning this system unless you have that serial number. So they're holding their software close to the hip, if you will. To be able to get it, you have to have a number. All right, so I guess that's about it. Oh, plus 16, so don't let anybody under 16 get on your motion system. Now let's take a look at the back. These cables get out of the way again. These cables are not very flexible, by the way, but heavy-duty cables rarely are. All right, so the first thing we see the big mains plug here. And we also have a switch for on and off, and this probably lights up, I would imagine. It's kind of clear, translucent looking red there. On the other sides, we have our data connections. So we have 2 that are called M-Bus. We have one in the middle that's actually dip switch. We got 2 dip switches there called config. And then we've got these others that are called ML up or down. And we'll get to that once we're configuring everything and plugging it in. And these dip switches are going to have to be configured based on the configuration we're using as far as having a 2 actuator setup or a 4 actuator setup, and where the actuators are located in the rectangle that is your simulator. Anything else we can talk about here? I think it's about it. Again, everything matches up quite well with this system, as you imagine it would. And yeah, I got no complaints out of the box what we're looking at here. It's really heavy stuff. It feels very substantial, and I think it's going to actually perform that way too, but we don't know it obviously until we get it on. One more thing I wanted to talk about on this, without a sticker, we do have an alternative mounting holes here. We've got 4 of them, one here, 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 and here. And of course they are M8s. So depending on how you're gonna have to mount your box, that's, you can use holes on the bottom, you can use them on the side, or you might have to prefab some brackets, or you might just let them sit on the floor as long as you got some rubber mats or something under them. So we'll just go ahead and get to our next segment. Now let's take a look inside of this controller box. First impressions, it's meeting my expectations from a company that makes, and has been making for a long time, very heavy duty motion systems for commercial solutions, all the way down to the consumer level or retail via the next level racing products. Good layout here. It's just clean. You can understand, easy to understand what's going on here. We have our AC coming in. They have their own dedicated conversion board here, a power supply board, if you will. It's going through a rectifying circuitry here. Then we're going through a choke filter. And then we're going through some more capacitors. We have a power transistor here with a heat sink on it. And right behind that, we have a lead coming off of this power supply board, going over to a Meanwell power supply. And this is a DC power supply, and it's putting out 24 volts. That's coming out on these white lines, feeding whatever circuitry needs or requires that 24 volts. Then we have, after that transistor and that little connection here for feeding that, another filtering choke. We have a huge 400 volt capacitor sitting here. And over here we have two fuses. So this is a fused power circuit board. So the fuses will blow instead of frying your whole board, which is kind of nice. The grounding scheme is very good everywhere I look. We have these huge lugs here for grounding to the chassis of the box, and we have another one up here. Yeah, everything is well done as far as the execution of the terminals. Again, it's meeting my expectations for the kind of company that Motion System is and what they've been doing for so long. I'm sure they've learned a lot of things through their years of research and development of best practices, if you will. We have the data board over here that's actually going to communicate with our driver boards. So this is our servo drive circuitry in here. We have two of them, obviously, because we're controlling two servos. These clips over here, as far as these black wires, they're actually RJ45 plugs, and they are shielded. You can see the metal shielding on there, as is everything in here. It's all about EMI mitigation at this point. And yeah, I think they're, like I said, lessons learned. They're definitely executing like they should. So these are all locking connectors here. So once you plug it in, it's not going to come out. And also a theme here is, again, showing their experience. All of the leads here, the important leads for power and things, these are all on screw down terminal blocks. And that's the most secure way to attach a cable other than just soldering it directly to the board. And then, of course, you have to desolder to do any maintenance. But this is a very good solution. Obviously, these motion systems are going to be incurring vibrations, right? Motion, things like that. So, yeah, this is definitely a good way to do this instead of just putting a Molex plug on here and putting some hot glue on it that we see in some circuit solutions that I've had before in here. We've got these two very large braking resistors up here, and of course, two of them for each side, each servo. And these look to be at least 150, maybe more watts. They're very large. I couldn't get the number off there, so I don't know what they are. But anyway, yeah, everywhere I look here, well executed. Even the fan motors here that are cooling, these got these huge heat sinks in here. I don't know how well you can see them. Get another angle. There they are. So these fans, even the fan connections aren't a Molex plug. They're actually another terminal block down here, the screw down type. So all these leads are screwed and securely attached there. As looks like the main power coming into each one of these circuit boards is also done the same way. Just everywhere you look, you see these terminal blocks as far as mounting things. A lot of grounds in here. We have a terminal ground in here against the chassis. Again, the same ground area everywhere. Let's see, what else is of interest can we look at here? All the boards, by the way, have motion systems on them. So, of course, this is their own proprietary designs, their own component selection, obviously, to get what they want out of this system. What else can we talk about? The fans themselves, the stickers are on the other side where the frame part is on the fan. That means that we're actually blowing wind that way. So we're sucking the air in from the top and blowing it on these huge heat sinks in here. And then that will come out the vents that are on the sides of the casement we saw before in the closer look. What else? Oh, yeah. And we also have two on each side, 400 volt capacitors down here. I don't know how well it's showing up. You can see the rim of them down here, I think. So, yeah, for more smoothing duties. Yeah, it's just a professional solution. I mean, it's meeting my expectations of what I would expect from Motion Systems being who they are in the industry. So, yeah, nothing I can see here that would set off an alarm bell. It's just professionally done, well presented. And again, tie downs everywhere. Everything's very neat and tidy. I don't know about you guys, but I like what I see here. Now it's time to get the actuators mounted to the cockpit. I'll be using this bracket that they sent me. Remember, this is an extra expense if you want to get these brackets. They are 60 euros a piece. They are heavy duty units, but they are expensive at the same time. So they give you these little packets of bolts with your brackets. And within this packet is smaller packets with some spring ball T-nuts, some 20 millimeter long socket head cap units, I believe these are stainless steel. And then we have these button heads. I already have a couple of these out so we can take a look at them. And these button heads are black. I am assuming that they intended you to use these to attach the bracket to the housing here, the actual actuator housing. So you'll have a black bolt on the outside of your bracket. It just looks better than a silver bolt sticking in there, right? There's the differences. So a little bit more aesthetically pleasing. And it's a button head, so it's a lower profile. All right. I'm going to be using something a little different. I'm going to be using the socket head cap, but I'm going to be using a black socket head cap. I'll be using these for the internal. In other words, when I'm attaching this to my profile itself, the bracket, doesn't matter what that looks like, does it? Because we're not going to see it once the actuator is mounted inside of here. I'm going to use some black ones. And the reason is I'm going to be taking this on and off. And as you can see, it's pretty obvious to anyone that looks at that. There's much more strength in this head than there is there as far as taking these things and torquing down on them and then taking them back off, things like that. These tend to wallow out a bit, although they have a nice look to them, being, you know, have that little radius to them, so they are pretty. But I'm going to use some black ones for my installation just because I can. I've got a lot of them laying around. So, but you can use this one-time installation or a couple times, no big deal, but I move my stuff around a lot and I just don't want to, speaking from experience here, that's all. These things wallow out, as you might imagine, quicker than this one will. All right, spring ball T-nut, which is nice because we can take that and there's a piece of profile here. It's an example. We can just roll these in to our cockpit without even pulling the end caps off, right? And they have the spring ball so they don't go anywhere when you shake them. Or you can use something else. If I was going to permanently mount this to my cockpit, my personal cockpit where I mount my actuators, I use these guys instead. And also use them in any of the structurally supporting joints in my cockpit. And you can see it's a bigger and beefier T-nut, right? And this one has a spring ball element in it also, so it doesn't slide around. I can put this in here like this. Go ahead and put this guy next to it. And you can see the differences as far as surface area contact and how much more secure. And you can actually put a lot more pressure on this one than you can this one. And these can twist in the channel a little bit, as you can see. And we have a nice raised area in here that also supports the space in between the channels, the lips of them, whereas this one does not. Now, there's a drawback to this one. There's no free lunches, right? It's always a compromise. That is, I can't take this one and roll it in. It's just too fat. Not going to happen, right? So I only use these on the joints I know that I'm not going to have to take off and do something else. So that's how I build the cockpits, with these guys, and I would mount the actuators with these. I mean, I've already spent all this money on this actuator system. It's not a big deal to go buy these. I think these are $1.50 a piece or $2 or something. So yeah, enough of these to do the job. It's worth it in the long run to me because I know it's going to be a more solid mount, because obviously we're going to have more gripping power on the profile than we do with that kind of T-nut there. Just a little thing of note. And I always use this in my personal cockpits. And I'll use these also, obviously, extensively, because a lot of times I'm just attaching something and I don't want to have to take the cockpit apart, obviously, to slide one of these things in. So these are obviously the champions when it comes to a system that's already built and you're just going to roll it in to attach something to your cockpit. Anyway, just want to point that out. Now, another thing about this actuator, they have, it's not just a screw hole in here. The first part of this, and it's not going to be easy for you, you just have to take my word for it. It's so heavy, and I don't know, it might be. Anyway, so there's like this plastic, hard plastic material here at the front of the hole to put your screw in. So when you first put these in, you're actually tapping that plastic with the threads. And that gives it just a, when I first thought, when I screwed it in at first, I thought there was something wrong, you know, but then I looked at it and said, oh, okay. So the plastic inserts in there, you don't see that very often, but that's just a way to keep vibration down so you don't have metal to metal contact, at least when you're putting the bracket on here. So without these, the bracket would be up against the metal. So that gives a little bit of push to the metal, if you will, even though it's very hard plastic. But yeah, as you put this in here the first time, it was really hard to get a bolt started. And I was looking at it, going, what's going on here? And then I saw what it was, these little plastic inserts at the very top. And of course, it's metal threads right behind that. So kind of a unique thing that I thought I'd show you guys that I haven't seen on an actuator before. That's just the way they do things over at Motion Systems. So yeah, I think I covered everything we need to know. And when we come back, I'll have this mounted. Again, it's no big deal. I'm just going to mount the brackets first to my profile. Then we'll come back with the actuators, put them in, and put the bolts in, and be done with that. And when we come back, we'll see what that looks like. Now, one more thing to think about here is these actuators are attached to our controller box, as you saw in a closer look. I could detach these, but that goes inside unplugging things and all that. So you have to move everything as one unit. So you have to plan for your move. Because remember, these things are like, what, 22 pounds a piece, 40, it's like, it's a very heavy unit when it's all together. The box is not so bad, but these things are definitely brick houses. So yeah, you have to plan for that. Maybe have a friend help you out moving it over to your cockpit when you're going to actually put them into the already mounted brackets. Now we have all 4 actuators mounted to our 4160 profiles. A pretty straightforward process here. No gotchas or really dramas. The brackets themselves, you want to make sure they are spaced evenly as far as with each other. The 2 on the rear need to be exactly the same amount of distance from the edge of your profile to where the bracket is. And you want to do the same thing on the front. About 230 millimeters from the edge there to the bracket on the front ones. The hardware for fastening the brackets to the profile. If you remember, we looked at the packets that they sent with the hardware, and they had those black button heads, and I made comments about they're not as strong as the socket head caps, which is very true. But it looks like you have to use those anyway. And I'll show you why. The spacing. Once you have this actuator mounted in its bracket, of course you have to line it up with the holes that are pre-drilled, then there isn't enough room in this bracket between the actuator here, and I put a socket head cap in there to illustrate. The button heads, you can see how much room there is between those and the actuator body. And the socket head cap would not have the same kind of room. In fact, you just can't use it. I tried, but you just can't use it because it doesn't give you enough slack in the space there to be able to jiggle this around as you're putting the bolts in, which you need to be able to do to get things started and make sure they run true and you don't strip anything out. So yeah, you do have to use those button heads in there. I would have liked to have seen these brackets spaced out a little bit further where you could get a socket head cap in there because it's just a stronger bolt head. End of the day, as I said before, and it's pretty easy to see that when you put them next to each other. But I was able to get enough torque on these that I felt was appropriate for this bracket and the motion actuators based on all the experience I've had with motion systems and bolting them and fixing them to things. So, all good there. And I use black bolts, by the way, the socket head caps for my brackets because I have black ones. Now, they have silver ones, obviously. In fact, that's one of them right there. And the reason they have silver, I was wondering about that because everything else is black. But if you go look at some of their cockpits and how you can add these kits, these individual kits of 2 actuators each, to other platforms they have, they all use silver hardware everywhere. So it's got this look to it, in other words. So it's kind of like their theme for the company, having silver hardware fasteners all over everything. You have to go to their site and look at it to see what I mean. But it looks pretty cool, actually. I think it looks okay. But anyway, back to this. We've got our controller boxes oriented so I have cables coming out of the back and out towards the front. So I can have them facing each other because remember, we're going to have to put cables in between here to put this in a master-slave configuration for these controller boxes. And of course, that's because they're individual kits, but they do talk to each other. And we'll see how that goes and what we're going to be doing as far as getting it cabled correctly. So yeah, no real dramas. Like I said before, everything went in pretty smoothly. Made sure I double-checked all the torque on everything. And typically when I get a system like this and I run it for a little bit, I'll come back and check the torque on all the bolts. I won't pull the actuators off and check the bolts in the brackets themselves down there because I made sure that I had those torqued down, and I came back and torqued them again a couple of times just to make sure that I had it where I wanted it to be. All right, so we'll just go ahead and get to our next segment. All right, so here's our controller boxes all wired up. And it was pretty easy to get this done. Just cabling, plugging stuff in. In the manual, when you're plugging 2 of these systems in together, they give you a nice diagram to go by. Very simple. And the one over here is the slave. And this is in a layout 4 configuration. So the slave, I'll show you some other pictures or B-rolls while I'm talking about this. The dip switches need to be in the off position on both dip switches. And over on the master, we have the left one in the on position and the right one on the off position. That puts it in that mode. So we also have connections that are going between the two boxes so they can communicate with each other. And we have our power plugs plugged in. We have our e-stop. And we also have the RJ45 running over. See it running down here. It goes over to the computer where our dongle is sitting. I can get over here and show you this. There's our little dongle. And of course, that's doing the signaling conversion to USB so the PC can control the unit. Now, I also have this guy over here. This is my 5,000 watt, 230 volt step up transformer. You can run the Q system either 230 or 115 volts. I'm going to do it in 230 because I want to be able to run that Q mode that has 800 millimeters per second performance and still be able to run the other ones too. So you can just use 115 volt. You just won't have access to the Q mode, which, to be quite honest, I don't think I'll probably be using in day-to-day driving. But we'll have to wait and see. So everything's set up. I've already tested it. Everything's working. Now all I have to do is get my cockpit finished. Got to get my pedal tray in and a seat on this thing and a wheelbase. Yeah, when we come back, we'll have everything configured, and we'll take a look at the software. Now we're going to take a look at the Qubic Manager. And this, of course, is where we'll be doing all our tuning and maintenance, things like that. First screen you get when you open it up for the first time is going to be this. And you can see we have a lot of different games supported here in this software. As you might imagine, Motion System's been around quite a while, so they have accumulated a lot of different profiles for games. And we have flight simulation, of course, racing simulation. We even have GP bikes. We've got roller coasters, all kinds of things in here. It's pretty busy, as you can see. So what you can do is make some of them the favorites, the ones that you use all the time, and then you would drop down and hit favorites. I don't have any favorites. Or you can go to only installed. And that's what is installed on this machine, my PC. Or only ones that I've been running in, which is iRacing and different profiles up here that I've collected. So you can clean it up, if you will, so it's not a busy interface like you see when we have everything selected under all. Okay, so what you're really going to want to do, though, is go over here to these tabs on the side. First one's going to be Tools and Diagnostics, and this is where you're going to set things up when you first get your rig up and running. We go to Devices, and we're going to want to see if all the devices are recognized. And this is opening up in my triple screen down here, so I had to pull it back up to my single so we can see it. And this device number 1 is the QS4, and that is, of course, our dual setup on our controller boxes, and they are set up in a slave master configuration. That's why it only shows one box. The rest of these are HVFMC100s, and those are our actuators. You want to make sure you see 4 of those, and they are okay, all of them. We have 1, 1, 1, 2, 1, 3, and 1, 4. All right, so that looks good. Now we're going to go to configuring. I'm not going to mess with leveling or quick codes because that's just something that's all customized as far as what you can do here in this software. The software runs deep, so you can do a heck of a lot of things to this stuff, even make your own little scripts, if you will, to do different things if you want it to on the system. But I'm not getting into that. It would take hours to be able to talk about that kind of stuff, and we just don't have that much time. But this is important, and we'll cover that. First off, how many actuators do you have? 2, 3, 4, or some extra ones? Traction loss, that kind of thing. I got 4, so that's why I have 4 checked. Now, the width and the length down here, millimeters, that's with our picture over here. And it wants to know from the centers between 1 and 2 and 3 and 4 what our width is. Currently, I am at 700 millimeters. The length on the centers is 1050 millimeters. This is important information. You need to put it in there because it's going to use that information as far as how it controls the motion. Stroke is 100 millimeters. We already know that. And layout is 4. There's a lot of different layouts you can choose here, but I chose layout 4. And this is what it looks like. The sequence of actuators is the right front is 1, left front 2, left rear 3, and right rear 4. And the front is that way and the rear is that way. So you have to make sure you have this right or it's not going to run right. So it's not that hard either. So most people, I'm sure, will get this right away. Now, also we have the list of the actuators here that tells us what the driver temperatures are, as far as the drivers in the controller boxes, the motor temperature itself, different motor trims. You can see we've got 3 of them that are pretty much the same, extreme to one end, and then one that's at 0. So I'm not sure why that is, but there it is. Volts DC, you can see our voltage across them, and identify. This is an arrow that we click, and it will actually bring the platform up to center and shake the actuator number 1, and then 2, 3, 4 individually, so you know that they're in the right position before you get started running the game. Pretty simple. Now, let's talk about heavy duty performance in Q mode. I have it on performance right now, and remember, if you watch the closer look, you would have seen me explaining what these different modes are and the differences in them. Heavy duty, I'm going to bring this up actually. Let's go ahead, and I have a picture down here. There it is. I think we can see this okay. The heavy duty mode can run off 115 volts or 230 volts. Now, as you guys know, if you've been watching, I'm running a 5,000 watt 230 volt step up transformer, so I can use all these modes. And here we can use either one, and that speed is 300 millimeters per second, which is pretty fast. We also have a limited acceleration of 0.4 Gs. The weight limit is 350 kilograms for heavy duty mode. If we go over to performance mode, we get faster. We can still run it off 115 or 230 volts, but we're definitely increasing our speed to 400 millimeters per second, and we are limited to 0.7 Gs. So our G-force is going up as far as acceleration. And that makes sense because we're going faster. 250 kilograms is the recommended load limit. And last but not least is the fastest one, which is Q mode, and that can only be run on 230 volts, and that is 800 millimeters per second over a 100 millimeter travel possibility. That's extremely fast. Maximum acceleration, 0.8 Gs, and we have 200 kilograms to load limit, about 441 pounds or so. So we're getting really small on limit here, and that's why I equipped my rig the way I have it without a shifter attached to it or anything, because I want to run Q mode and see what the differences are. But I've already been running this back and forth in different modes, and I've kind of settled on performance mode for my basic all-arounder. Of course, that's subjective. You might have a different way of looking at it or feeling, so there you go. Now, let's go ahead and get rid of that. So this is where you would select what these modes are. And it won't change the mode until you click OK. But you see what happens when I go over to Q mode. I want you to see this. Before you activate Q mode, please confirm that you understand and accept all risks. Well, that's a good warning, isn't it? Nice as a lawyer pop-up. The motion platform will generate violent movements in Q mode. And it has a little star there. It says, check your product's user manual for detailed description. Q mode requires a 230 volt AC power source, and it is a reduced payload. I confirm that my system meets these requirements. You have to check both of these, click yes, and then you can use Q mode, right? But I'm not using Q mode right now. I will talk about that in the driving, that I did use all modes and my thoughts on them. So there you go. Now you have all this set up. You click OK, and we're back to leveling. And this is, again, this stuff runs really deep. The software here is what you can do. And you have to click on generate base signal. If my rig starts going up and down, you can't see it, but it did that. And it shows you what the balance is. So again, this is just one of the many, many things or tools that you can play with on this system. So we really don't need to do that because I feel like I'm balanced anyway. Quick codes, this is some codes that you can get from the manufacturer to test things, or if you're experimenting, and these are special codes. So help quickly configure your device, internal calibration and features. We don't use any of that. So we'll go ahead and get out of the tools and diagnostics over here. Click that again, it all goes away. Now you also see there is a lot of stuff in here under tools and diagnostics. But I'm not going to go through all this because it would take me forever. Firmware update is the last one, which is obviously you're going to want to make sure your firmware is updated when you first turn on your system and you open the Q Manager. It will actually tell you that. In fact, I just did an update because it told me I needed an update. Games integration. This is where I'm going to bring this back up, where you might need to set up the game. You can see all these games that are listed here. It says not installed because the game has not been found. So this is where you would go and do any special configuration requirements. Set a Corsa, here we go. Nothing to configure because we already did it. program files that, of course, anyway, this is just a configuration utility for games that are listed and supported, but we do not have here. All right, so we'll go ahead and get out of games integration. Help and support. This is another screen that pops up. Let me bring it up here. And it gives us information currently what we're doing here under General tab, and that is the version is 2.12100, and that is the latest update. I just updated this app today, actually. Serial numbers for different things, the platform Q4, steering controls, there is no steering controls, device count is 5, which is good. You can actually do a show details, and we're back to, hey, the devices thing where we were before. So we don't need that. I can go in here and say check configuration, changes, new features on the latest version. That's what that is, just a log. Snapshot, you can take a system snapshot basically for troubleshooting or for your own records. Repair, feedback monitor, uninstall things, enable different things, so I'm going to leave that alone too. Privacy, this is where you can check up on your privacy to make sure that you're not giving away your data. Third-party integration kind of things. Again, this is stuff that we're not going to be using. Diagnostics, this is just a list of what's going on with our processors and the platform. This is the kind of thing you would probably be using for troubleshooting with the manufacturer. USB tree, and this tells us, this is pretty cool, tells us where this is located in our USB tree here on the standard hubs. It's actually listing all this stuff that it's picking up on your computer. All right, so that is help and support. And of course, if we go to general, there's also some help in here for, let's see, I guess this is just what we will be copying to give to the manufacturer for help. All right, Action Center. This is something that comes up. Let's see if I can drag this up. No, I got to disable this little warning that came up that said everything seems to be configured. So if you needed to update something or something needed to be changed, like a firmware update, it would be listed in here. And over here on the tab, this Action Center tab, it would be a yellow color or orange saying, hey, check it out. Go over here and see if there's something you need to update, right? Mine's all updated. Motion compensation, and this has a good motion compensation app in it already as far as the physics and things like that. And you just step your way through mapping the motion compensation system. And it explains good explanations here for different things. Screenway experiment, I'm not even sure what that is, I haven't used it. System integration, multiple motion platforms. This, again, you can do so much different stuff here. Different SDK things are available. Tricks and tweaks. Advanced settings. And Varjo. If you got a Varjo, it can help you configure the Varjo. If you guys don't know what that is, that's a newer one that's come out as of the date of this video. That's been out for a little while now, but not that old. And a lot of people have them and can use them. All right, so that's our VR setup for motion compensation section. And that's it. Then we exit program. So there it is. There's everything you need to know. Now, what we really want is what we're going to be using. Go ahead and close this tools and diagnostics. We're going to go up here and I'm going to go back to the only users. And I'm going to set up, I'm going to open up my ACE. I think it's my ACE, isn't it? Yeah. ACE only. There it is. And this is default configuration. Well, that's not default. I'm going to put this back up to 1. That's default. Now, you can always go back to default configuration down here. See this button? If you change a bunch of stuff in here, you can just go, okay, I'm going to go back to default itself. Actually, that's not the configure I want. That's the more complicated one. Let me put that back to default. And then we're going to go, where's the one I was on before? Hang on a minute here. Let me go back to all. Where's iRacing? I'll just go to installed. There we go. That's the one I want. I believe that's it. Yeah. Motion Basic. Okay. So this is the latest one, and it's called iRacing ACE. And this layout is pretty simple. I'm going to go ahead and go back to my default again. I've been messing around with it a bit. And I'll say yes. And these all go back to 1 over here. And it kind of sits off to the side here of the main app. See the main app background here? So it doesn't really go anywhere. So that's where it's going to be. I can't drag it around. All right. Run the game. If you have it mapped on where the game's installed, you can click that and it'll bring up iRacing. I just usually start iRacing anyway before I do anything. The subjects we have here, the options are boost, response in all areas. Okay, so this is the main sledgehammer slider. So you can set up your gain, maybe higher, lower, sharpness of that gain, and you can do it for roll individually, pitch individually, and heave. Keeping it simple here, so you don't have to be worried about a bunch of other settings, because there are plenty of settings that you can go to in the Motion Advanced, and we click on that, and there they are. Overall, again, the gains and things like that: body roll intermittent, body roll sustained, body pitch intermittent, body pitch sustained. And the difference between these, according to what they're saying here, is you boost or reduce motion platform response related to vehicle body pitch, angular velocity. Angular velocity and pitch. So that means you got to be moving for this pitch to be angular velocity. If you're not moving, then it's not really a velocity, is it? It would be sustained. What sustained means is boost or reduce motion platform response related to vehicle body pitch angle. Like if I'm on a hill or I'm on a embankment, then this will lean one way or the other, and I can adjust that on the sustained and adjust on doing, like, I'm going to braking threshold or I'm accelerating. So these are two different things that are different. Turning rate. Boost or reduce the motion platform response. That means body yaw, angular velocity, even though we don't have true yaw in this system. It's only 3DOF. That is an adjustment for it. They try to simulate it, or they'll put a setting in there that makes it feel like you're doing something with that yaw. Vertical G-force. This means up or down. So yeah, that's how we would do that. What's that? Heave, right? So yeah, that's what they're talking about. Longitudinal G-force sustained, longitudinal G-force sustained, regular longitudinal sustained, lateral sustained. Then we got some weight transfer bias. So if you want to, I figured this was something like, if it's rolling too much one way or the other, you could make it roll harder on one side or the other. Road harshness. This has to do with heave, so you can put more gain on your heave there, and that would relate to vertical G-force also. So it's kind of, there's some stuff that's tied together here, as you might imagine. Road harshness, how much do you want to feel the road? There you go. Side slip, and that's like oversteer, traction loss, even though we don't have any yaw or true sway here. There is a setting for that. All right. And I've played around a little bit in this, but to be honest, I really got a pretty good setting just by going in here and messing with these guys. So keep it simple is my motto, and I'm sure most people will just want to do that. But there'll be some of us who want to play when we want to and just get on with it when we want to. So at least you have options here. And this is, again, this is not the most complicated part of this application of what it's capable of. All right, so special effects, SFX. And the first one is rev limiter, and it has different settings here for that: intensity, bias, gear, and percent. And this will be a tactile feedback you can get for the rev limit of the car that you set up. Gear change effect. This is overwrites gear shift effect embedded in the longitudinal acceleration signal, so you can play with this. Remember, this is special effects. So if you don't like what you're getting from the default telemetry feed from the game you're using, then you can adjust it here. And we can go gear up intensity, gear down shift intensity. And I usually go take the up and move it down a little bit because I don't like it bucking too much when I'm going up. I like the downshift intensity though. And that's subjective. Wheel slip threshold, rumble strips, different frequencies for our rumble strips, so we can tune those in if we want. Violent movement threshold, and this is for crashes. You don't want your system going nuts when you crash. So it's kind of like I would call this a spike filter. Violent movement suppression time, and you can adjust this to what you want it to be. So if you crash, then you can limit the violent movements. For default is 3 seconds. And you can go higher or lower if you feel like you're in a situation where you're going to be crashing a lot. Maybe you want more than that. I don't know. Engine vibration intensity. I'm not a big fan of engine vibration, and I usually say that on these motion systems because of the newer GT cars. They vibrate. The RPMs are such a high rate. It's more of a buzz to me. However, if I get a looping V8, like a Super V8 car or a truck or something like that, or one of those NASCAR cars that have those really high horsepower, high torque V8 motors in them. If it's a looping V8, it feels pretty good. But otherwise, it just feels kind of buzzy to me. So that's where I would be doing that. All right, so there's the detail part. As far as SFX, there's your advanced motion. If you're not getting exactly what you want when you're in motion in the basics, you can go in and tweak over here and play around with these settings. And we'll go into the next tab, motion post-processing. And this is where you can actually change curves on the pitch and the roll and the heave. I told you this goes deep. All right, so there's a lot of things we can do here. We can adjust the linearity, the gains, offsets of those. Yeah, so I just leave them all linear. I don't want to have curves, but you might want to. So again, more stuff you can adjust. Veer headway, eliminate screen distortions caused by motion platform movements. That means it's supposed to compensate. It's just another compensation package. Pitch, heave, and smoothness. So you can play with that if you have this set up for your VR. Basic settings, center, park, stop immediately. This happens when you pause the game. What do you want it to do? And usually it's around the center if I want to pause the game anyway, so I just say keep it there. Instead of park it, it just drops it down. Not harshly drop it down, but it just goes down. I like to just leave it where it is, and so I can get right back to where I'm at. Simple sharing. This is a way to share different configurations with other people. Motion, tactile, things like that. I think most people that buy these systems are going to be like me. They just want to get in and have some fun, right? So you would use Motion Basic and get on there and just have fun, and then tweak later on if you feel like you don't get enough out of this. Now, that's it for the app. Again, this is just a very low-level overview of what this app is capable of. And yeah, you could spend hours messing around with this thing. So what we're going to do next is just get in and see how this works as far as in a live tuning session, how hard or easy it is for me to come up with something that I feel like is replicating or what I feel like the car should be doing when I'm actually driving it in iRacing. So we're in the Q Manager, and we're going to do some tuning here in iRacing. We're in the iRacing profile. This is the default one, the ACE they call it. And everything is set to 1s here on the basic. We go to advanced, everything is 1 down there, except for I think the shifting or something. Well, that's SFX. Everything is 1 here. Overall is 1. SFX, that's where we have some different numbers. So that one is, let's see, engine vibration intensity. Everything is turned on as far as engine stuff and rumble strips and gear change. I got a feeling that's going to be a bit much for me. Rev limiter intensity is turned off though, because that's something that you might want to have or might not want to have. But they do have the shifting and the engine vibration on from default, and I'll probably turn that off straight away. But I just wanted to get you guys to see what it looks like when we get in and run it at first. It's probably going to be a bit much for me. In fact, I know it will be, but we'll see what it does. So let's go ahead and get in here and get to it. All right. Ferrari 488 GT legacy car, GT3 legacy car. Sebring, as you guys might recognize this as we go along. And I got to turn this, hang on, this volume up just a little bit. There we go. I still want to be able to talk and you guys hear me, but I still want to be able to drive. All right, first off, it's got a lot of motion. Look at the pitch. It's a sustained pitch too. You notice how as I keep stopping, it tilts forward even more the harder I put on the brakes. However, it's doing a very good job as far as reacting to how much brake pressure I'm putting on the pedal, but it's just moving too much. The roll on this, yeah. The roll's a bit much too. There's no way a GT car is going to roll that much. And the engine vibration, you can't see that, but I can feel it. That's got to go. This is a high revving motor here, and it just doesn't feel good to me. Other people might like it, but I just don't. Also, the shift points are very, I don't know if you can see that, but I'm bouncing pretty good on the shifts. So yeah, there's a couple things we want to turn down here straight away if I'm going to be able to drive this at all. All right, so first off, we're going to get into this engine vibration intensity slider. I'm going to turn that down, and that is going to kill the vibrations. Whew. Thank you. All right. Again, so I might love that. I just don't like it that much. 30, I'm going down to 10 on here on the upshift intensity. And on the other one, downshift, I like it a little bit more downshift feel. I'll take that down to 15. And I'm going to leave everything else alone because I kind of think it's going to be fine. We'll go back to basic now. So let's go ahead and take the overall gain for roll, pitch, and heave combined, and we'll take that down to, I'm just going to take it down to like 45. And you can click on the arrows here and just incrementally advance it at the same time. Or you can hold it down and it'll keep rolling back and forth. I like the way that it does that actually. So I don't have to do too much to get it to go the way I want it to. All right. So all we did was turn off the effects that I didn't like. But what I'm really focused on is how this chassis is going to move. Do I feel like I'm in the car? That's my main mission here. Not to feel like I'm in a amusement ride. I want to try to simulate what the car, at least as best what I would think it would do when it's racing down the track, and it was doing way too much before. Okay, that's, yeah, the roll's quicker and not as much. I like that. Yep, and the pitch is not pitching as much. So right there, I'm liking what I'm feeling. Now what we got to do is get up to speed here, and we'll start feeling some of the, yeah, the curbing is good. Not too harsh, but not too soft either. Maybe just a little soft. Let's see here. Let's try these rumble strips. Okay, the rumble strips are good. I mean, all I've done was turn a couple of things off and come back on the overall gain, which again, like I was saying, most of the time when you get a default configuration from a motion system, the manufacturer dials things up and puts it what I call in exhibition mode so they can show you the capabilities of the system, of course. All right. That feels pretty good. I'm getting some good heave. Now, there's not a lot of bumps on this back straight, but coming around this corner is where we get a lot. And so this is a good test right here to show me what's going on. Lets me know what's happening. And yeah, I can feel the individual areas being, or what I call local tactile feedback on these as far as what the suspension's doing. Get good bumps coming down the straight there. Not too much roll. Great rumble. Maybe a little bit more pitch than I would like. And the roll is a little bit, maybe it's not too much pitch, it's just the way it comes on. So what we're going to do now is stay in the basic, because this is where most people are going to play around with this anyway. I mean, just because we go over here to advanced, and you can see all these different body roll, intermittent, body roll, sustained. Then we come down to our GeForces. We've got intermittent, sustained, vertical, longitudinal, lateral, weight transfer, all this stuff. That's fine that we can do this. I like that the selection's there and the capability is there. However, I think a lot of people would rather just stay right here and tune from here with just 4 things to adjust. If, and that's a big if, we can get where we want to be. I'm going to boost the overall gain up to 125 from 1. Let me change that again. It went all the way down. All right, so 125. I'm also going to go, let's just do that and see what we get. I just want things to happen a little bit quicker on the roll and pitch axis. Yeah, it's quicker now. I like that. It's not as slow or lethargic. Maybe that's a bad word for it, but it just wasn't quick enough for me. Good transition over that concrete patch. Good transition there. Still maybe a little soft. The bumps are good. I'm coming across that part. Tell you what I'm going to do. I'm going to go back and take my sharpness back to 1 on overall. Let's do this individually. Let's see if we can get this down to individual. I'm going to go up on roll. I'm going to go up to 125. And gain for pitch, I'm going to go up to 120. Not gain, rather, but this is all sharpness. Because it feels like it's going a good distance as far as the travel, but it's not clear. It's not crisp. And that's what I'm looking for. And heave, yeah, we'll go ahead and, it's doing pretty good, but I'm going to go ahead and sharpen that up to 115. All right, let's see what we got. Okay. Okay, roll is quicker, a little snappier, so sharpness is working. Bumps are good, heave is good. Remember, I'm just trying to get the car to feel like I'm controlling it. With weight transfer, which would be the roll, because we only have 3 DOF to deal with here, or to work with rather, so it's a little limited to exactly what we can do versus like a 6 DOF system. But this is feeling pretty good right now. I could tell right away that the sharpness adjustment is definitely getting me where I want to be. I didn't have to do anything to the gain. Yeah, that feels better, much better coming across, or rather around turn 17 with all the bumps. Let's see what the straight feels like. Yeah, everything seems a little bit quicker now, or so I don't know if they speed it up or they take some damping out, whatever that slider for sharpness does, but it works. Oh yeah, this is feeling pretty good right now. And that's what I like about this system. It's not hard to get a good tune. They've done a pretty good tune right out of the box. It's just amped up. Everything's just too far, like I said, exhibition mode. You bring it down, and then we can fine adjust. Like I said, I'm trying to find out if I can get exactly what I want in the basic without having to go into the advanced and playing with all these other things. And I think I have. It feels like I can interpret what the car is doing based on my inputs on the steering wheel and on the pedals under acceleration, deceleration, and of course under braking. Yep. It all has to kind of mesh together. In a motion system, if it can't feel like it's on time with what you're doing with your steering wheel inputs and your pedal inputs, it feels disconnected somehow, a little vague. And this feels right on to what I see. That strip go roll into the front wheel and the back wheel, and you can actually feel that transfer from the front to the rear, especially over these sharp parts. Go back to third. Great bumps as far as the rumble strips. They're not too sharp, they're irritating, but they're not so soft as feel like that I'm running a big fat tire on here that's like a four-wheel drive truck that's had the air taken out of it. And the shifts are pretty good too, right? I just was thinking about that because I changed those. Yeah, I feel like I'm really controlling the car now. And that's what's important. Down the straight feels good the way I like it to feel. Not too much pitch, and it comes on quick enough that it makes me feel like my inputs are controlling what the car is doing as it should, at least as my brain is mapping it out as it should. And this is just going to lead to consistent lap times. That's what it's all about anyway. If you know what the car is doing and you can feel it, then you're going to be much more consistent because you get the same feeling on the same parts of the track whenever you roll over them. And if it doesn't feel the same, then you know something's wrong and you need to correct. In other words, you got into the turn too hot, you're coming out too soon, your apex is blown because you're rolling over dirt instead of rumble strip now, that kind of thing. And you can feel these differences. Of course, you can see them too. But it's nice that everything is being confirmed with motion. At least that's the way I see it. Yeah, it's good transitions there. Yeah. I can feel slip, understeer, and oversteer before it happens. You're able to put the corrections in time so that it doesn't happen. So yeah. And this is what a motion system should be able to do. You shouldn't have to spend hours trying to get the thing to where it feels like the car is doing what I think it should do. Now, somebody else might get in this with this setup and go, this feels terrible. And that's cool, because we all feel things a little differently. We all react to motion a little bit differently, and what we're seeing and what we're feeling in the steering wheel, what we're doing with our pedals. So everybody's a little bit different in the timing and what they're feeling. So there's no problem with that. Get it tuned to where you feel like the car is doing what you think it should be doing, and you can feel that. So in other words, you're getting data or information fed into your body that helps you realize what the car is doing, weight transfer on the pitches and the rolls, things like that, oversteer, understeer, when it's just at the edge of breaking loose. If you can feel that in your suspension, it really helps you be more consistent in your lap times. And that's all what I'm really after when it comes to circuit cars. Now, of course, we can amp this up and get all kinds of big travel out of it, and you'll see that in the driving segment once we get into the dirt with a rally car and we get in with the Lucas oil trucks. I always do that. Then that's the time to turn things up, I think. But when you're on a circuit car, you really don't need that much travel anyway. So I think that we got a good setting here. I can use this and be consistent with this because I already know I've been doing it. I've got maybe 25 hours on this system. And it's really done a good job for me, and that's all I really can tell you. So yeah, we'll just go ahead and get on to the driving segment. We're in iRacing at Sebring and the Ferrari 488 GT3 legacy car, my usual test bed for my baseline testing. Now, when it comes to a motion system, what I try to do is get it to become a system for data retrieval on what the car is doing as far as its suspension is concerned. And this gives you information that you can use to help you control the car. And of course, it adds immensely to the immersion. If you have 4 points of suspension on your chassis and it's moving just like a real car would be moving, maybe not just like, but very similar to what a real car would be experiencing on a track. Now, this data, as it's streaming in, is telling me about weight transfer. It's telling me about how hard I'm braking, as far as how much pitch there is in braking. It tells me a lot of information about the road surfaces and what bumps I can go over in a turn without skipping, and which ones that I have to avoid or slow down for so that I don't lose the car. It will tell me when the car is getting loose, and that is in tandem, by the way, with your direct drive wheel, these feelings that you get from this. So that's what I'm trying to do. Now, out of the box, this system was in what usually I call exhibition mode, and all manufacturers do this for their motion systems, and that's to demonstrate to you right out of the box just how much motion you can get out of this and what it's capable of doing. And of course, the first thing I did, if you watched the live tuning session, was turn that gain down to about half on overall. So, and then we went in and we did some more adjustments in the sharpness and didn't really mess with the gain on the individuals. But the biggest thing here I found was I was able to pretty much stay in the basic tuning tab where there's 8 different sliders to use there, and was able to get a very good feel for what the car was doing just using those sliders. And I think that's important that you can do that, but it's also important that we have the advanced slider that you can go in and then really do a lot of tweaking if you so desire, if you think there's something else that you can get out of it. So I think that their application here covers a lot of that and does a very good job as far as the availability of these different controls you can use to dial things in. And the special effects actually does a pretty good job. It didn't feel canned to me when I had it dialed into where I liked it, so I think it did a good job there. Now watch this jump as we go over the rally car here. Now watch that landing. See how soft that was? That was a good landing off the jump. And the reason I'm saying that, we're going to watch the jump. The second jump wasn't such a great landing. And you'll see the difference in the way this suspension system is acting when that happens, because the telemetry is telling it that, oh, by the way, this is not a great jump. You're a little off axis here, and we'll see it just in a second. And you'll see it come down. It's going to be a sharper hit when it lands. And that's, in true life, that really happens. Now watch how I got off the edge here and watch this landing. See how it jerked more there? But not too much, because we have that soft landing, or we have what I call their spike filter. So when it's certain frequency, a real big hit comes in, then that filter will gently go through that. So it slows it down so you don't get a big shock to the system. And not only that, you don't get a shock to your mechanicals on your actuators. So it's better to have that going all the time. It's a lot easier on your actuators, so you get a longer life out of them. We're going to go over the jump one more time, and I'm not sure if this was a soft one or not. It may have been. But you can see how it lifted up and rotated around the top of the jump, the apex, as we came over the top of it. And that's very convincing also when it does that. So in dirt, also you'll see some bumping going on. If you watch the suspension, see that? Now when you're in a real dirt track, I don't know if you've ever been on one, but they're not, nice smooth dirt. They might be at first, but they get really ruddy and grooved pretty well, pretty quickly. And then it's a very jumpy, bumpy ride, if you will. So the track conditions in dirt are always changing on a dirt track during a race. But yeah, it's good at replicating that too, the bumps in that dirt. And I think I have I'm not sure which landing this one was, but it might be another soft land. It depends on where I hit it here. It looks like it did a little wiggle there when it landed on that one. Now, of course, we have to take it over and turn the gain again up a little bit more for the dirt trucks. Now, one thing I noticed about the dirt trucks here is, first off, we're getting a lot more motion. It's doing the same thing as far as rotation, and it's a blast to do this. It's a lot of fun. But when I got out and I'm looking at the video and I'm watching the motion system, I really have to focus on, it's hard to see both things at once because you're watching the screen or you're not watching the screen because you have to look down at the motion system. But my point is, it looks to me like it's behind or it's delayed. And this is not the first time I've seen this when I'm looking at the actual video. When you're going through the whoops there, it just doesn't seem like it's on time. But the strange thing is when you're sitting in the cockpit, and this is impossible for me to convey to you guys, it just is. You got to be in it. It doesn't feel like it's lagging. It feels like, you know, a big 6-inch, 8-inch travel, whatever the suspension is on these trucks. It feels like you're actually making contact as soon as you make contact with the ground, even though here you really have to look hard for it and kind of not pay attention to what exactly is going on. You have to look down at the frame and just kind of peripheral see what's going on in the monitor. But yeah, if I was looking at this in the video, I'd be saying, man, this looks like it's behind. It doesn't look like it's on time. But when you're in it running it, you don't feel that way. And again, any motion video you see, it's not a good example or a good representation of what you would feel in the motion system yourself. You have to be in this thing. And I've had people come over and try this and say the same thing. It didn't feel like it when I was in it, but then they're looking at the video and they're going, my God, it looks like it's just a little bit behind, but you really have to focus on the suspension and keep the peripheral on the end of the jump, and you can see it actually does a pretty good job there. But again, you have to be in it. Now, of course, you don't hear any more sound because we're going to do silent running. I'm going to let you guys listen to this for a while so you can hear what it sounds like. Okay, so we're back with sound now, and again, this is not any louder than other suspension, long travel suspension systems I've had here at the SRG. It's about on par, I think, with like the Prosimuse or the PT actuators, things like that. You know, you're going to get a lot of motion like this, you're going to hear them moving. So that's all there is to it. And not only that, but you might want to put some matting underneath if you live above somebody with a system like that so they don't hear it thumping so much. If that's even possible, I don't know. I have a concrete floor, so I don't have to worry about it. Thank goodness. So, yeah, I can't really complain about anything that this system does, and I'm not surprised by that because Motion Systems has been doing this for quite a long time in the commercial market. They've been manufacturing motion solutions for other companies. A good example of that's Next Level Racing. They manufacture their motion systems. So yeah, I'm not too surprised at how refined this feels out of the box. All the adjustments that are available, there's a lot of things that you can drill down and do with this system that they allow you access to, which is kind of surprising to me, to be honest. And yeah, they just let you do some things that really can fine tune this, but you could also get lost. But it's great that they have that basic tab so you can just get a pretty darn good setup just using that. At least in the basic I could. Even when I was doing it here, I could also. So like I said, it's just an all-around good system. It's not surprising to me. I pretty much expected this from Motion Systems. Like I said, they have some pretty exotic motion solutions that they actually manufacture. And you can go to their site and look at some of the stuff they have. But yeah, overall, you know, the system does a good job. It is meeting my expectations for a 4-inch plug-and-play, at least what I would consider to be a plug-and-play, just out-of-the-box system. And at the price, you know, only you can determine if the price justifies what you think this is. But if you're interested in motion systems, you pretty much all you have to do is go take a look at their website and the kind of things that they build. And then you might give you a better idea if you think this is something along the lines that you're looking for. Final thoughts on the Qubic Systems QS220PL actuator kit from the guys at Motion Systems. I received 2 of these kits, which Motion Systems calls their extended set for a true 3DOF motion system. The kits came well packaged in their retail boxes. They present it as a good top-tier product with very good fit and finish. Each kit consists of 2 QSL1 actuators and a QSSB2 controller box. which can be set up as a 2 DOF system with an available pivot mount placed in the front or the rear of the cockpit. The controller boxes look to be made with high-quality components and a well-thought-out circuit board design. These kits do not come with mounting brackets. I used their QS mounting bracket, which lets you attach the actuators to a profile cockpit from a 4080 size profile to a 4160 sized. They are very heavy-duty brackets, weighing in at almost 5 pounds or 2.23 kilos. They will set you back an additional €60 each. Mounting the actuators was achieved without any dramas with the included hardware kit. Once mounted, it was time to get the required cables attached to the controller boxes in the proper order. The included manual makes this a rather easy thing to do. Motion System uses their own in-house developed configuration and tuning app called Qubic Manager. This looks to be a very mature application that supports many games. There are many adjustable parameters in this application. The tuning waters can run very deep here. Fortunately, they provide a basic tuning tab that allowed me to get a setup dialed in where I had a good feel for what the car was doing on track, just using the 8 provided sliders in the basic tuning tab. The system has an SFX tab where you can tune engine vibration, shifting force, road surface, and other things if you want them. Driving the Qubic System 3DOF setup was a very good experience. I was looking for something to pick on here, but it performed as it should. I will give one complaint. I would rather see the mounting brackets included in the price for these kits. As it is, you will need to spend another €240 to get them, or fabricate them yourself. Not really an option for most people looking at purchasing a motion system. The QS220PL is a professional-looking kit that is well thought out and executed, what I would consider to be a true plug-and-play system. When you consider how long Motion Systems has been making motion systems for their own commercial customers and the simulator industry in general, I'm not really surprised by the quality of the kit I tested here. I'm Barry Rowland. Thanks again for watching the Sim Racing Garage channel. Don't forget to hit the subscribe button. And if you would like to help support what I do here at the SRG, visit my website at simracinggarage.com.